Welcome to the New Year's break. Uh, so, in our last session, we did an introductory session for the entire data engineering track, and we went through few basic stuff, I guess. From today onwards, we will start the technical track, and we will begin with SQL again. But this time, we're going to focus on leveling up our SQL, especially in PostgreSQL. In our foundation classes, we have already covered the basic stuff like select, join, group by, and those kind of things. And now what we're going to do is we're going to focus on how, as a data engineer, you are actually going to use SQL um, that will be implemented in your future pipelines. Where we are, what we're trying to do is we're trying to learn to write SQL that is readable, that is reusable, and that is also good for analytics. Uh, there will be most probably a couple of sessions or maybe 3 sessions regarding advanced SQL. And for today's session, we will not be focusing on performance. It'll be probably next session or the session after that. Today's session is primarily focused on writing. If you have to implement a very complex logic using SQL, how to do that, and how to do that, plus how to do that in a more clean way, how to move away from subqueries and correlated joins and correlated queries, how to move away from them and implement CTEs. We'll also look at window functions and some features, some advanced features that are specific to PostgreSQL, features like JSONB and arrays, because even within tabulated data, so even when your data is in tables, in rows and columns, data might not always be perfectly normalized within that. And that is where functions like JSONB and arrays function from PostgreSQL helps us. Okay, so our database is already up. Let me share my screen. The database is already up. Now, before we begin, what we're gonna just give me a second here. Okay. Uh, so what we're going to need is we're going to create a small data set which mimics banking data. It's not going to be large. It's going to be a little small data set, but it'll be enough to understand and be realistic enough to demonstrate the patterns that we will be going through today. Uh, Keep all the files here. So these are the queries that we will be running, and let's just go through what is exactly being done over here. So we're checking first to see if there is a schema. And if it is not, then we are going to create a schema. Inside of that, we are creating tables for customers, for accounts, for merchants, and for transactions. We are also creating 2 indexes. And we will not be diving into indexes for now, just so that our hands-on demonstration today are smoother. We are creating these indexes. So we're going to insert some data inside all of the tables that we've created. And that's about it. So let's execute this and see how it goes. If everything runs successfully, at the end, we should be getting the row counts from all of the tables. So let's see. Yeah, it's already done. So we have these four tables and we have these records inside of them. Um, okay, so set underscore path to in Postgres database. Um, will often find this statement being run if you're working on Postgres database. Let's talk about what this statement does. Okay. So this statement in PostgreSQL, what it does is that you're telling PostgreSQL that whenever you are writing SQL statements and running them from maybe DB or maybe any SQL tools, whenever you are running a query and you have mentioned a table or you have mentioned a view, whatever you're running, um, and you have not mentioned its schema name. So, for example, let's go to uh, so we have this table D underscore week one, right? Normally, if you want to select table from select data from this, you do select asterisk from DE underscore week one dot and then whatever tables you have inside of it, right? So let's say dot accounts. Normally, you would do this. Okay, and we do this because we can have multiple schemas inside a PostgreSQL. So just so you know, just so we don't access another table from another schema by mistake, we access our objects inside our database in a particular schema in PostgreSQL like this. But uh, that is one way to work. The other way to work is if we are sure that we are only going to work inside one particular schema and we're not going to be accessing data from any other particular schema, we can just write this one statement at the top, the first statement at the top. And what this will do is whenever you are accessing any object without mentioning the schema, by default, PostgreSQL, that particular tool, will understand that, okay, he or she is asking for information from a particular object. The schema has not been mentioned, but because this statement has been executed, by default, it will go ahead and check in that particular scheme. So when we execute this in the first line, we don't have to execute our statement like this. We can just go ahead and do this. Okay. Now, just to give you an example, if I execute both of this, it'll give me the output like this. So it knows that I am trying to access accounts from this particular schema. Okay, so let me just let's run this query and talk about what's happening over here. Okay, so here, if we look at the output, um, we are seeing a couple of things over here. If you look at the output over here, I don't know if it is all visible or not. Okay, so we have the customer information, and then we have the account information, and as you can see, there is a one-to-many relationship almost everywhere, right? So from customers to account. So you can see R of Shrestha and R of Shrestha over here. This is the same customer, but it has got two accounts. One is a checking account, one is a savings account. There probably is. So Nisha Karki, no, not Nisha Karki. Uh, which else? switches. Okay, this is just one example. So we have between customer data and accounts data, we have one-to-many relationships, right? Then from account to transactions, we will all we will basically we will have one-to-many relationship, right? Um, so this is one thing we are noticing over here in this data set. The other thing is you can see the metadata over here. So it's basically capturing the IP address, the channel, the device information, and a note in every transaction. Right? So it can be something like the remarks that we put in every transaction that we make. And so we have this metadata information also in the table, which is in the form of JSON, right? So this kind of data set is pretty much the kind of data set you would be seeing in data engineering. Um, because no matter how much data modeling you do, uh, these individual tables, the data in these individual tables might be fine. But when you are working on analytics, you will have to be joining multiple tables and bringing in information from multiple tables, and the output result would pretty much be like this. You have one-to-many relationships, you have information within structured table, you have unstructured data. Okay, so this data sets mimics kind of like a real world scenario. So what we are going to do over here is this messy output from this particular query that you're seeing, we will try to create, convert these, um, we'll try to write some SQL statements that will be readable, that would be, uh, what do you say? Um, that would be readable, that would be reusable also, and that would be the kind of the SQL query that you actually write in analytics. Okay, so let me show you a query that works, but it's gonna look very messy. Okay, it's a kind of query you write when you are maybe only focused on the output, not focused on what SQL statement you are writing. And so maybe after a week or a couple of weeks, somebody asks you to change the query maybe or adds a requirement, and then you come back and have a look at the query, and you yourself don't understand what the query is actually doing. Okay, so uh, we're going to write a query which is going to answer a question. So like, let's say in the last few days, which customer has the highest total spend, and the number of transactions, the count of the transactions. Okay. So so the simple query for that would be, let's say, we need the customer ID, um, we need the full name, we obviously need to add up the amount and count the records, right? Uh, say not total orders, let's do transaction count. Uh, the customer information comes from customers, so let's do C. We have to join accounts E. So E dot customer ID equals to C dot customer ID. We also have to join transactions on the account ID, where T, T dot posted, not T dot status equals to not completed, is to posted. And t dot ts underscore event is greater than equal to 2026. Let's do 0101. That's 545. And t dot ts event is less than 2026. Let's do 1 and 6. Then we are going to need to group by c dot customer ID and c dot full name. So here we're going to need c dot customer ID, c dot full name. Amount is from transaction, and that's about it. If we run this, character 70. Okay. So we have this, which is fine. Okay, so from here I mean, this gives us the output, right? It gives us the customer information, how much they have spent, and the count of the transaction. The query is not terrible, but you know, mm, it could be done better because this does its job. If there is any other additional requirement added to it, it might become messy later on. Right? Maybe let's say if they ask to filter out some certain transactions or maybe some certain type of customer or some certain types of accounts, you would have to write a lot of filters over here. You could have, uh, um, based on the requirement, you would have to keep on, play around with this query a lot. Uh, and what this does is in SQL is that whenever you write a messy query, it becomes hard to maintain. It becomes hard to document also. So let's say you write this query and then normally what we do is we write a query on a SQL file and then we would add a comment on top saying that, okay, this query is for such and such purposes. Now, at the moment some additional requirement is added, we make the changes and then we either overwrite this or add more comments to this, and then we get confused later on. What if we remove this and let's say um, change this query and then update this comment. Later on down the line, our original work has already been displaced. So it gets hard for other developers to come back and have a look at what this query does. Why is this query the way it is? Those different kind of questions. That's basically related to the maintainability of the code base. Now, uh, in data engineering, from the mindset or from the viewpoint of a data engineer, we don't write queries like this. I mean, for this particular example, this query works fine. But normally, when we are writing queries for the purpose of analytics, we don't write a query like this. So what we do is we make use of CTEs. And the way we use CTE is we treat SQL statements like a pipeline. Okay. And there are usually 3 steps that we follow. Step 1 is we define the base rows, basically. So, which means that what basic information is being asked and where do we get it from. Second step is to enrich them. So, in this particular example, what is being asked is the total amount of the transaction and the total count of the transaction, right? We only need these 2 information, which basically comes from the transaction table. So First of all, we're going to pull all the information from required information from the transaction table. That's the first step. Second step is to enrich them. Enrich them basically means um, what additional information should be provided along with your transaction amount and transaction count, which is basically the information of the customer. Right. Right. So then what we do is also we may need the account information also. So then what we do is after we have pulled in the total transaction amount and total count of the transaction, then we join that subset of data with your accounts table and customer table, and then add your customer information and account information to that. Now that's done. That is our basically full setup information that we require. The final step is then after that we do the aggregation. That is what we do, right? And in this way, we kind of like create a stepwise pipeline where we only pull in information. We pull in the required information, we enrich them, and then we aggregate them. And um, the best way to do that would basically be by the use of CTEs. So this same query that you are seeing over here can also be written this way. Okay, so we say with base underscore transaction as we're gonna say select transaction underscore transactions, and we're gonna copy same thing over here. The ID. We need account ID. We need the TS event. Let's say we need the amount. We need the status. And let's also pull the metadata. Okay. All right. So that's our step one, which is to get the base rows. All right. The next thing we need to do is enrich them, right? So we're gonna say enriched as, and in here what we're gonna do is we're gonna say select something from base underscore transaction, which is this. We're going to select information from this, and then we are going to join our accounts table and our customers table to this. So from base underscore transaction, let's say B, and we're going to join accounts A on that's fine, and we're also going to join customers on that also works fine. And what are we going to select? We're going to select C dot customer ID, C dot full name, A dot count ID, A dot count type, B dot transaction ID, B dot TH underscore event, B dot amount, and B dot metadata. We're going to do this much. So that's the step two. Now, from the initial select where we selected all the rows from our transaction, We enrich them with customer information and account information. We do that. And now finally what we do is we do the aggregation. So we need the total amount and we need the count of the transaction. So we're going to say customer underscore, let's say summary as select customer ID, full name, some amount as total amount, count as transaction as account, and we're going to get that information from enriched. Uh, we're going to group customer ID and full name. So that looks fine. And then finally we say select customer underscore ID, full name, total amount, transaction count from customer summary, order by total amount, descending limit, let's say like we do this. Let's copy this, put it in here. So that is what our query is going to look like. You know, if I select this and run it, uh, transactions. Oh, it's transactions. It should work now. And so we have the output like this from the CTE. Yeah. Okay. Now you might be thinking the second version that we wrote using CTEs, which is acronym for Common Table Expression. This is quite long, right? Compared to this query is quite long, but it is also easier. Uh, you might be thinking that how is a CTE, which is what about, uh, let's say, 40 lines. The CTE is 40 lines, whereas this is what, 5, 6, 7, or 7 lines of code. How is a 40 line of SQL statement easier than a 6 or 7 lines of code? In data engineering, normally, this is much easier. The only reason is it's easy to maintain um, in the long run, right? And to kind of like explain that, let's say, for example, um, you wrote this query, and then tomorrow somebody comes and asks you, uh, I only want, I want this same information, but I only want it from, the checking accounts. Okay. Now, if you do that in this particular first query that you have written, it becomes a little bit, if you are only going to, mm, difficult in the sense that not exactly difficult. How to explain this? Mm, proper way to you know answer if somebody comes and asks you to update this query to so that it only gives results for checking accounts, let's say, for example. um, the reason it becomes difficult, because it becomes mentally harder, because the query is written as, you can see, it's one big block of logic where you're doing everything there, right? You're doing filtering over there, you have all your joins over there, and the aggregation is also being done in the same block, right? And if somebody comes and asks you to do for, let's say, checking account, you would probably do and a dot account type is equal to checking. This is what you would do, right? Now, uh, because everything is happening all at once, we are joining customers' account and transactions. We are filtering by status, transaction status. We're filtering by account type. We are filtering by the transaction date. Right? We have everything. We have everything going on together. And when you add new requirements, you have to, re-understand the whole query every time somebody asks you to change. So this query was doing something else. Now it is doing something else, right? Next time somebody comes and asks you to make changes to this query, you have to come and have a look at the query, and then first go through the query to understand what exactly is happening over there, right? And the more conditions you add, here right now there is only three conditions, and the more conditions you add with time, this single block of code, right? It'll become crowded. It'll become fragile. Um, and It's change coming in. You have to look at the query and understand what that query is doing to be able to make any further changes. Now, with that logic in mind, come over here and have a look at the CT. You know exactly what each block is doing. This block is pulling in all the transaction. This block is enriching. This block is doing the aggregation. Now, in this particular query, if I tell you to make the same change, where you have to uh, filter according to account type checking, um, where do you think I need to change in this CT? Do I have to make change in the base transaction? Do I have to make change in the enriched? Or do I have to make change in customer summary? Where do you think I have to make the change to get the same output? Can someone tell me?
Enriched section.
Yeah, that's exactly right. So all you would have to do is come over here and let's say where a dot account type is equals to checking. That's all you have to do. And it becomes easier. It becomes easier to maintain. You understand, just by having quick look at the CT, you know exactly what each individual block is doing, and any requirement that comes in later on, you can easily make changes. So compare that to, like, this is a very simple piece of analytics query. Just to give you an example, uh, I did this just to give you an example. Normally, you would be writing SQL queries that's like 40 to 50 lines of code. And if you are not making use of CTEs and if you're writing queries like this, even you yourself will not be able to understand what you have written after a week. If something goes wrong or if you have to come back and make changes, it's a headache. And normally you don't write one single piece of SQL query in data engineering, in analytics. You'll be writing hundreds and hundreds and lines of SQL. You would probably be writing a lot more SQL code uh, than just one block of SQL code. And so it is very important that instead of writing SQL queries like this, you make a habit of making CTEs, and you make a habit of writing CTEs in a pipeline process or a pipeline method, where first step is to get the base rows. Second step is to enrich them if you are pulling in information from multiple tables. And then finally you do all the aggregations and sorting or whatever final business logic you need to implement. And then get at the end you get the output that is required. Okay, so there was a question. Let me uh, answer that. So does it also affect on performance? When it comes to CTEs, yeah, um, you can say that CTEs can affect performance, uh, but not always. You have to keep that in mind. Um, in newer versions of you know PostgreSQL, it would depend on a couple of things. First of all, it will depend upon um, the version of Postgres that you are using. So when we were using older version of Postgres, so up until I think Postgres 11, your CTEs used to be materialized. Um, so in that scenario, your CTEs used to be slower in Postgres 11 and previous version. In Postgres 12 and above, uh, it works more like a view, not like a materialized table. So it is much faster. So uh, that is one of the scenarios where your CTE would be faster. Uh, but then the other way is, like if you have a very complex, if you've written a very complex SQL block of code, and especially where you have to reference the same data or same subset of data from one table or a join of multiple join, and if you make use of CTEs in those scenarios, yeah, then your CTEs use of CTEs becomes much more faster. Um, there are scenarios where even if you use CTEs, it'll be slower. So, for example, these we call these intermediate results: search underscore path, sorry, base underscore transaction, enriched, and customer underscore summary. These are our intermediate results. And if any of these intermediate results are very large, that means that the output from these intermediate results have to cannot fit in the memory and have to go back and be written in the disk or cache. In those kind of scenarios, your CTE's performance gets worse. The other scenario is the planner can sometimes push the predicates down. Um, and so what happens is when you push the predicates down, um, you Postgres database is actually processing more rows than it needs to. And when I say predicates down, which basically means that in, let's say, this particular SQL block, these are all the predicates. So I am saying that I only need rows from transactions where these predicates are true. But sometimes what happens is that it doesn't happen always. Sometimes it can happen that the planner will not look at these predicates. It will first go and pull all the records from the transaction and then look at the predicates. which is filtering. Those kind of scenarios, sometimes, not always, sometimes um, CTEs can be slow. Okay, so let's. How many SQL lines you have written in one query? Huh. It would depend upon the kind of job. So the first job that I did, which was in Nepal in various information technologies, where I was basically a SQL developer, I think I wrote uh, SQL codes which were anything between 150 to 200 lines of code. Uh, so just one SQL statement. If you're talking about a whole script, as a database administrator, I have written, I think about 4,000 to 5,000 lines of code in one SQL script. But there were multiple SQL statements, obviously, there. So it depends. But yeah, like one SQL statement of 150 to 200 lines, that's like pretty average, you would say. When you're, especially if you're working as a analytics engineer, that's like pretty average. Okay, so that was about CTEs. Now let's look at window functions. Okay, um, so we already have group by, which does aggregations, right? Now, what group by does is that it collapses rows, as we've already seen in the basics. Basically, your group by statement, it collapses rows, right? Um, and so we tend to, mm, kind of like, so I'll just show you an example. Let's say in this same query, we did group by to get the output, right? So these are the customers, and these are the total amount they've sent, and these are all the transaction count. Now here we also had account information, but we didn't include that. And so what happened is that those rows basically got collapsed. Now we don't have account specific information over here. Uh, and so what Windows functions does, or it gives us the or is good at, is that it gives us the ability to analyze data while not exactly collapsing any rows as much as possible. Which means that it gives us the ability to look at one row of data in our entire data set or in one table and be able to compare quantitatively its value, its specific value, against the entire table or maybe aggregation of the table. That is basically what window functions allows us to do. Right. So, for example, let's say if somebody asks, okay, so for each account, show me the latest transaction. Now, if you don't know window function, you would probably write some joins, you would probably write some correlated subqueries, and give us the output, right? Again, you can do it, but that's not the way to go about it. Um, when you make use of window functions to deliver that particular output, it becomes pretty easy. So we'll just have a look at that. So um, window functions. Okay. So again, so because I said that we should be using CTEs, so most of the queries that you will see in our hands-on, they will be using CTEs basically. All right, so with ranked as select what we need is we need all the information from transaction. So we're going to say t dot asterisk, and then we're going to say row underscore number over function by. We need top transaction, right? We need the no, we need the latest transaction for each account. So we're going to partition that our information or our data set based on our account ID. We can order by ts underscore event. Descending is rn from transactions t. We don't need this information. Right. So we have all the transactions and we have the ranking of each transaction for their individual account ID, right? Account type, basically. So we have that information. Now, all we need to do is select account ID, transaction ID, TS event, amount, and let's do status from ranked, where RN equals to 1 and order by account ID. That's all we need to do. Status is not there. It is there. So why? Um, status is there. Big. We don't need this. So these are the latest transaction for each of the account that we have in our dataset, right? So very simply, we partition by account ID, which basically means, and we have used the row underscore number. So what we're doing is we are doing a separate ranking for each account, and we are ordering by transaction event descending, which means the newest transaction is first. And because we are doing a row number, each row for each transaction for your account gets unique row number inside each partition. So now let's say if somebody asks you if two transactions have the, let's say, same exact timestamp, um, what will row underscore number do in that particular scenario? Will both of those records get ranking as 1, or it would pick one as first and the second as 2? Can somebody tell me that? Okay, yeah. We have to understand that row underscore number function, it always gives us a unique row number. So even if you have your same timestamp for 2 records, one of those records will get row number value is 1, the second will get 2. And so in that particular scenario, what happens is that if you have, uh, you know, that kind of data set, um, where let's say you have got two transactions in same transaction timestamp, having same transaction timestamp, and if you are using a query like this, then you are not giving the correct output. Why? Because you have the latest transaction for, let's say, account ID one, the latest transaction, you have two transactions with the same transaction timestamp. But if you are using this particular query, you are only giving them one latest transaction, whereas that's not the reality. And so in that kind of scenario, what you can do is instead of using row underscore number, you can use your um, ranking function, the rank and dense rank function. So which is basically what we use when there is a tie in ranking and you don't want to miss out on the data set if there is a tie. If there's a tie, if there are conditions, so like I said, if there are conditions in a data set, let's say in this particular data set, if you have same transaction, if you have multiple transactions on the same timestamp, and if you're using row number, you are losing out on the actual information. But instead of row number, if you're using rank and dense rank, uh, if there are multiple transactions with the same timestamp, that reflects as your correct output and it will be shown by that query. Okay, so this was just an example of ranking query. Now let's write another ranking query, which would be more meaningful probably. So let's say they ask you to write for each customer, rank the merchants by total spend, right? So which basically means that somebody asked you to find where does our customer spend the most, right? So looking at the data set, you would probably try to figure out, okay, let's write a query that finds out for each customer which are the top merchants that they are sending to. So let's say, am I spending money in Bhatbetini? Am I spending money in Pathao or Kathmandu? Or am I spending money in Daraj? Where is my card being used most? Merchants means basically that. Merchants means the shop or the business where you are spending the money. So that is basically what the question is. Where does the customer spend the most? And spend the most means the merchant information. And that is what we're going to figure out. So we're going to say see week one. We're going to say with, let's say, spend as we need the, let's just do from customers C. We're going to join accounts A on A dot customer ID equals C dot customer ID. We're going to do join transaction on A dot account ID. We are also going to join merchants m dot merchant ID, t dot merchant ID. This is fine. We're gonna group by c dot customer ID, c dot full name, and m dot merchant name, not ID, name. And we're going to select a c dot customer ID, c dot full name, m dot merchant name, and we're going to add t dot amount as total spent. All right. So here we have our base information. Now, with the base information ready, now we are going to do the ranking. And in here, all we need to do is say, select asterisk, comma, rank over partition by. We need to partition by customer ID. So because we need to know for each customer, and order by total spend, descending. And let's say spend underscore rank from spend. We have the ranking ready. So what we're going to say is customer underscore ID, full underscore name, merchant underscore name, total spend, and we also need the rank, spend underscore rank from ranked, order by customer ID, spend rank, and total underscore spend descending. Let's run that. Argument of choice must be type boolean. Let's see. Oh, sorry. Join accounts A on A dot customer ID equals C dot customer ID. And we have like this. So this customer is spending the most on Travel Hub. This customer is spending the most on Mado Online. This customer is spending the most on Skyline Hotel. Okay. So for each customer, you see their merchants, you see it is sorted by spend, and you are also seeing the rank. Okay. So uh, this is how you make use of the window function, right? Now, there are other examples, but I'm going to leave that for now and provide you assignments for that, so you will have um, a little bit of deeper understanding of that. So, for example, let's say um, the use of um, let's say um, let's say I want you to find out the running total basically, which is pretty common if you're working with banking data or maybe financial data. So, which basically helps us in answering question like how much has a particular account spent so far, or maybe deposited so far, some fixed time, maybe something like that. So something like that. Uh, so that's probably going to be one of the assignments for you to figure out to write a query that helps you figure out how much a particular account has spent so far over time. Uh, I'm going to introduce to you a concept in PostgreSQL that I talked about, which is your JSONB and arrays. Okay, and this is very useful and very common if you're working as a data engineer. So let's start by talking about first about JSONB. Okay, and to help you understand, you first have to look at your transaction table. Okay, so we had to look at this earlier in our transactions table. We had something like this, right? Metadata. Our transaction table has got metadata. And this transaction, this metadata column in our transaction table includes information like a channel, the ID of the device, even the IP information, and your remarks or your notes, right? So let me write a simple query that will make you understand what exactly JSON-B does. So I'm going to say from transactions T, uh, this is to order by TS underscore event limit. And I'm going to say transaction underscore ID. I'm going to say TS underscore event. I'm going to say amount. Now, what I'm going to do is I'm going to extract information from the metadata column. So let's say we have your channel information, your device ID information, IP information, and node information. Now, let's say I want to extract channel information from that metadata column. So I say we have the metadata column, right? From this, what I want to extract is channel as channel. That's all I have to do. Metadata. Maybe I want to extract device ID information as device underscore ID. And I also want to extract IP as IP. That's all I have to do. And if I run this, you can see I've got the channel information, I've got the device ID information, and I've got the IP information from your metadata column. And all I had to do was make use of this operator. Okay, uh, pretty straightforward. Now, uh, we can use this operator if you've got JSON information or JSON data inside of a column in uh, Postgres table. What this operator does, is that you are basically accessing the key value pair. So what I'm doing from this particular line is over that I'm saying that I'm accessing the JSON data on metadata, and I want all the values for this key. So in the JSON metadata that you saw, that there was key value pair, right? So I'm accessing the value for this particular key. That's all I'm doing. Same is for device ID and IP. So I'm accessing the values of channel, device ID, and IP using your individual key. Somebody has asked, is there any specific name for that operator? It's I think it's called the JSON text extraction operator. Um, Basically, that's what JSON-B is. Uh, I mean, JSON or JSON-B fieldless text operator, or in simple terms, it's a JSON text extraction operator. That's it. And the syntax is basically your JSON-B column name, and you give this, and you specify which key you want to extract the values from. That's it. So that is about your working with JSON data inside of your table. If you've got a column with JSON data, that is basically how you can work your way out. Uh, there is a question. Um, can we use filter on that operator? Yeah, I mean, you could basically do something like, uh, metadata channel equals to what channel do we have? US, right? So you can do something like this. You can do something like this. It's pretty much the same way. So if you have got JSON information in a column in your Postgres table, you can make use of this to access your individual key value pairs and return values for specific keys. Uh, and then be able to, you can use this as a column and group on that column. So you can do something like from transactions T by uh, you can do something like this. You can do groupings on this. You can do filtering on this. You can even do ordering. You can do basically everything that you would do on regular columns. So that's how you would work with JSON data if it is in a column in your database. Now, another concept is your arrays. Uh, so let's see. Select customer underscore ID, full name, tags from customers. Okay. So here we've got something different. This is not JSON data over here. This is basically an array, right? So you will also have, this is different to JSON. Now, this is more like a list, you can say. You remember the list in Python? So uh, in transactions, we had JSON data where you had key value pair, which was more like a Python dictionary. Here you have something like a Python list where you don't have key value pairs, you just have strings or text in a comma separated uh, enclosed by your square brackets, right? Now, in this kind of scenario, uh, to be able to access these individual information, you can't use JSONB. You'll have to use arrays. And let's say, based on this, you have, okay, so what do we have? This is basically kind of like, okay, tags given to customer based on requirement. So if account holder is a student, maybe if the account holder is kind of like, salary account, if the account holder is a VIP person. So based on, the bank's internal process, they have maybe a system to tag customers to be able to find them. And usually tags in most systems, they appear like this. They appear like a comma separated value in a single column. And so if you have something like that, you can't use your JSONB. You have to use something called tags. And let's say from here, I want to find out VIP customers. So the way to do is where tags, and then I'm going to say at the rate greater than, and I'm going to use array, and I'm going to say I want only VIP, and I want the text. So this is the syntax for using arrays. This operator that you're seeing at the rate greater than, it basically means contains. So what I'm trying to say is where tags contains array with value VIP. Okay. The array is not, this array is not a function. I'm saying that tags, I want to search for VIP in tags where tags is basically an array. That's what I'm doing over here. And this text is for extracting that text information. So now if I run this, you can see that all of these three customers have got VIP tag inside of them. Okay. Uh, Now that is one functionality of tags. The another functionality of tags is that working with tags can be cumbersome. So let's say somebody asks, okay, how many customers are there for each tag? Somebody might ask you for the report. Here we were only looking at a specific tag, and basically we were filtering on the data set. But instead of filtering, if somebody asks you, uh, you know, um, give me the count of customers or give me any kind of report, maybe some aggregation or application of window function for each individual tags that we have, then what do we do? So then what we do is we do select, and what we're going to do is customer ID, and we're going to use the function called unnest tags as tag from customers. Okay, let's see the output of this first, and then you'll be able to understand what this function is actually doing. So now you're seeing what this basically does. You are seeing that. So for customer one had two tags, VIP and salary. So using the function unnest, it actually returned two rows for the same customer, but each row has its unique tag from your uh, tag array, basically. So customer 4 has got two tags, customer 8 has got two tags, and customer 1 has got two tags. The rest have got single tags. Right. So now that you have information like this, where you have each individual customer and each individual tag, now you can basically count your unique customer, right, for each of your tag. So you can basically say select tag and count asterisk as customer count from this, say X, and you can say goodbye tag followed by customer count descending tag. It could be something like this. And now if I run this, you get the count of customer for each of those tags. Okay, so this unnest array and JSON B, uh, filtering JSON-B, the JSON operator that we just had a look at. The JSON operator, the array contains function, and your unnest function. These three functions, uh, they become quite helpful to you as a data engineer, because even inside of your uh, relational database management system, where you have got structure in rows, columns, and tables, you will end up with data set inside individual columns where there is unstructured data like arrays and uh, JSON data. And so it becomes important that you know and understand how to use these functions to be able to access that data and work with that data. Uh, okay, so that was pretty much it that I wanted to cover today. Uh, I wanted to cover a few more examples, but I'll give that as assignment to you to kind of have a look at how much were you able to gather today. So what I'm going to do is all of these SQL queries, let me uh, save them. And so I'm going to upload the datasets to SQL and the SQL query.sql to GitHub, and provide you the link to the GitHub repository, so you can pull down both of these SQL and play around by yourself uh, regarding the concepts that we talked about. And I'll be uploading these tomorrow morning. And I'll also upload your assignments for CTEs, for Windows functions, and for JSON-B and array. So just simple, easy, one question each, using the same data set over here, same sample data set over here that we are using. So that's going to be your assignment. And I think we are almost out of time for today. So before we wrap up, if you have any questions or comments, do let me know. Um, I'll go through your questions and comments if you have any before wrapping up today's session. If you have dweaver, it's easier to use dweaver than using Visual Studio Code. So if you have dweaver already with you, go ahead and keep using dweaver. That's better and easier. Dweaver is much more friendly if you are working with SQL. The questions or comments? Okay, well, if there are no questions or comments, let's wrap up and end our session for today. And I will catch you all on our next session on Wednesday. Have a good evening and a good night.